Hello everyone. So back to this topic, creating two-way frequency tables. So yeah, last time we just discussed on two-way frequency tables. Two-way frequency tables are where you have frequencies on both ends. So basically you have some data on the left end and you have on the right end. That's basically a frequency table where you're having some data. So you're like having this person is a male or female, and then their income amounts. So say male is earning less than 20,000, or if a male is earning more than 50,000, something like that, he could have female is earning less than 20,000, female is earning more than 50,000. That way, we can just make a table, two-way table where you have like this data here, this two columns, and these two rows. This data is matching to both of them. So like here, if we see, let's actually try this problem and see what do we do here. Basically, now they're asking us, Lee knows the following information about the 50 days where she tracked whether she wore a tie and whether she received a compliment on her outfit. So now she's just tracking she wore a tie or not, and did she receive a compliment on her outfit or not. She's tracking, the relationship between the two. There are 11 days where she neither wore a tie nor received a compliment. So what does this mean? 11 days where she neither did both of them. So what happens? Did not receive, and where she didn't wear a tie though. Okay, she did not receive a compliment, but she even didn't wear it. So therefore, this thing and where this thing, where do they match? They match over here. Did not wear a tie, did not receive a compliment. Neither of them. We just fill in 11. 11 just gets in there. Now, they're saying 11 days in total where she received a compliment. Now, they're saying where she received a compliment regardless of wearing a tie. Okay? They don't know specify did she wear a tie or not. In total, where she received a compliment. So, in total, how many think received a compliment here? That should be 30, right? Yeah. Received a compliment regardless of we don't know if she wore a tie or not. Here's the 30. Now, there are 16 days in total where she did not wear a tie. So 16 days in total where she did not wear a tie. Now, 16 days means what? 16 days where she did not wear a tie. So it's basically 16 days up here where she did not wear a tie. So that should be 16 in total. Okay, now we have all of this information here. So now we know, well, now because we know this is 11, right? This is total is 16 where she did not wear a tie. So where maybe she might have did not wear a tie and she didn't receive a compliment, if that is 11, maybe where she did not wear a tie, because in total did not wear a tie, she didn't wear ties for 16 days. So we might consider, where she's maybe not wearing a tie, and if she's missing a compliment, that part, I'll just write a different color. That could be 16 minus 11, that is 5. Okay, that's 5. So now what we do here is, now if we know this part is 5, now we can figure this out because we know in total she received 30 days compliments. That's what we know. We know in total she received 30 days compliment, regardless of whether she wore a tie or not. 5 times she did not wear a tie, she received a compliment. That's how we figured out from the bottom value, figure out the upper one. Now from 5 to figure out the left value. So something and 5 together is 30. And what is that something? That's going to be 25. 25 days she wore a tie. Now, we have all of this information here. Now, what happens here is now they do specify here 50 days where she tracked she wore a tie or not. So 50 days means in total this should add up to 50. Okay, I'll just write in purple. 50 is the total days she tracked all of this. So if this is 30 where she received a compliment, this one should be 20. Right? Because 20 plus 30 is 50. If this is 16, then 16 plus something equals 50. Remember, because 30 plus 50, 30 plus 20 equals 50. 16 plus something over here, whatever thing is there over here, equals 50 as well. So 16 plus what equals 50? 34. Yep. So 34 plus 16 equals 50. That means 25 plus something equals 34. What is that something? That should be 9. So there we go. We have 25. I'll just fill in here. It's 25, tab 5, tab 9, tab 11. Yes. Now if you try to add all of these values here, 20 plus 5, 25 plus 5 is 30, 9 plus 11 is 20, 20 plus 30 is 50. There we go. We have it up there. Perfect. There we go. We got it correct. Let's check this out here actually. So come and just kind of study this up here and see, close up, what do they mean here? So basically now they say there are 11 days where she did not wear a tie or receive a compliment. There must have, yeah, been 16 minus 11. Because, this way we can figure this out. Because we do know that 16 days she did not wear a tie, the same thing they did here, okay? Two-way frequency tables. They just figured out that she received a compliment and she did not wear a tie was 5 days. Then, I mean, like, if that is 11 days where she did not receive either of those, neither a tie, neither a compliment, and if in total she had like 16 days where she did not wear a tie, so maybe which other days could she have received a compliment? Because 11 days she didn't receive a compliment. That's what we know. So that could be 5, right? Because 5 plus 11 is 60. And then that ways, 30 minus 5, they did 25 on this end. So we got 25 on the number of days she received a compliment when wore a tie. Because in total there were 30 days where she received a compliment. And then we just did the same thing. 50 minus 25 plus 5 is 11. which has got 9 over there. So yeah, this is a two-way frequency table. Let me just get the simplest definition, two-way frequency table. Two categorical values. Oh, I see, yeah. It's basically, so you guys get it, right? Two-way frequency table is just basically, two categorical variables. What is the relationship between the two? If someone is doing this, someone is, say, male, whether they're doing English class, if they're female, what they're doing Spanish class, like that. You're just tracking the relationship between two categorical variables by comparing the counts. So comparing the counts of data points that belong to each one. So basically, you're just comparing the number of the quantity, I would say, the quantity in each of those specific those specific variables with each other to kind of map around how the relationship is going on and just kind of map around. So we just want to compare the relationship between the two, and therefore we use these two-way tables. So yeah, there we go. Now so here also we want to measure is two categorical variables, and two categorical variables are like vegetables or you like fruits or not. So, we're just mapping the relationship that, okay, these many percentage of people who like fruits actually like vegetables. That ways. Okay. And then we just want to draw a Venn diagram. So, Venn diagrams is basically, where we have a universe. It's kind of two universes. And what is the most common thing between the two? That's 23, right? And here they're just saying there's 40 members in a food club. The Venn diagram below shows how many members like vegetables, fruit, both, or neither. So we can see here 23 like both, right? Because they're between the two. 8 only like fruit, 4 only like vegetables. Okay. And yeah, that is the basic point. And five like neither, because five are outside of the two ones. So they're like neither of them. And then what does neither mean? Neither means do not like fruit or vegetable. Neither of them. That comes over here. So this means this part is going to be this five. Okay. Now, who like both of them together? That's 23, right? Well, because between the two. They like both of them. 23 is like both of them. Yeah. Now, like vegetables means they don't maybe like fruit because they're not in the fruit category. These four people at least. They're not in the fruit. They're not towards much of the fruit. They're mainly toward veggies. So we just have to kind of map here now which of them like vegetables, but not like fruit. So like vegetables, but not like fruit will be over here. That'll be about four. And now who like fruit, that is eight. I'll just draw in different color. Eight. Who actually like fruit, but they maybe did not like vegetables, right? Because they're just into fruits, not only vegetables, like these 23. 23 people out there who like both of them. Eight maybe just like fruit, they don't like any vegetable, I guess. So yeah, eight comes over here. And even if we try to add here to just kind of see if we get 40, we will get 40 because 8 plus 5 is 13. 23 plus 4 is 27. Yeah, 27 plus 13 is 40. So yeah, there we go. Now, if you just try to put all the values over here, we just try to insert 27, 23, 4, 8, and 5. Perfect. Now, Nikita knows the following information about a food club that has 11 members. Let me erase this. And yeah, three members like neither fruits nor vegetables. So do not like fruit, do not like vegetables. That comes in here, three. Four members like fruit but not vegetables, but not. But not means what? Just fruit. So like fruit but not, yeah. They like fruit but not vegetables. Yes, not here because they don't like both. They just like only fruit but not vegetables. That should be four. And now five members in total like fruit. So in total, how many like fruit? How many? Five. Okay. So that means if this is four, this is five, this means to be one. Okay. This is one. Now 11, right? 11 is total. Now we want to just figure this out. Who like vegetables but who do not like fruit. So what do we do is now we have 3, 4, 1. So we can just take is 11 because we know in total this should be 11. So 11 minus, now we subtract all of the thing we have till now. We just figure out the missing unknown who like vegetables but do not like fruits. So 11 minus, we just sum of these values, okay? Because we just want this box. We know that all these four boxes added together equal 11, but we don't know this box over here. This is unknown. So we add this together to get 8, and we subtract 11 minus 8 to get that unknown. That is, excuse me, that's 3. So yeah, three like vegetables, but they do not like fruit. And then if we try to add all of these values, 1 plus 4 is 5, plus 3 is 8, plus 3, another 3 is 11. So yeah, Nikita can map around like that. Now, a veteran is asking 18 patrons if they have a dog, and she also asked each patron if they have a cat. So just taking the like if you have a dog, you have a cat, and if you have neither also. We're not gonna just showing, because some people don't have pets, so that basically we just want to even model neither. Neither actually is zero. Okay. So do not have a cat, do not have a dog. We'll just say zero. Another thing, just when time we're just showing the data she collected, and we just want to fill in the two frequency table to map the relationship between the categorical variables, namely having a dog and having a cat. So basically, seven people, if we see, seven people have both of them, right? Seven people have a dog and have a cat in the Venn diagram. There's seven. So we just fill in a seven here. Now, how many people have a cat? If they have a cat, maybe they don't have a dog, okay? Because there's six are just here. So how many people have a cat? There are six. So where should we put the six? Do not have a dog, right? Yeah, so six over here. Have a cat, but they do not have a dog. So like in this way. So yeah, it matches both. Okay, do not have a cat, but they have a dog. Is five, right? Because five just have a dog. Five. And 7 plus 5 is indeed 12. 12 plus 6 is indeed 80. Yep. Uh-oh. Okay, there we go. Okay. Now researchers, so now this is analyzing two-way frequency tables. Now we're just trying to, make up a fraction and just kind of map the difference, map the, I guess, percentage. These many percentage have like this many income, but they are, let's say 72% of males have 40,000 and above, something like that. So most males are kind of middle income. That ways we can map. So that is the main thing we're just trying to do here. So same thing they're just giving here, researchers are just surveying recent graduates of two different universities about their income, following to a survey table, two-way table, displays the data for the sample of graduates who responded for the survey. Income, University A, University B, and then the total. So these are all the incomes. These are all the universities, and then the total has been given here of graduates in a sample. What fraction came from University A? Okay. How many students, first of all, students in total do we have? You have 300. How many came from University A? 160. Perfect. This is the time to make a fraction. If you ate two slices, say you have a pizza, okay, I ate two slices of this. What do I say? Total are four. How many I ate? Two. Two over four. Or half. Half of the pizza I ate. So this way also we can say how many are from University A? 160 are from there. So 160 over how many in total do we have? 300. Yep. 160 over 300. That is over. Yeah, there we go. That is this option D. Okay. Let me resolve this and yeah. Okay, so researchers once surveyed the students on which superpower they would last like to have. To following survey table displays the data for the sample of students responded to the survey. What percentage of students in the sample were male? So yeah, that was asking how many in total and how many were male. Yeah, good questions. Yeah, this is kind of like where you want to use a lot of data analysis skills to kind of like see how many were how many months of these how many months of these businesses did we have male customers. That ways we can change our products that ways to more attract them. That ways it's used in data analysis projects. So it's used in the real world, these kind of stat stuff in frequency tables, especially. Frequency means it's just modeling around like frequency, how much this time is occurring. Like five people are buying this, so five is the frequency of this, six is the frequency of this. That way frequency is. And let's just yeah. Number of times a specific value is occurring. Okay, relative frequency, you guys know, right? Relative absolute frequency we have. A lot of frequency we have, like cumulative frequency, just add up the frequencies and stuff. We'll get into that later. For now, let's just discuss on this part. So how many students were in total? We have 100. How many were male? 50. So 50 out of 100. So 50, 50. 50 were male, 50 were male. Total were 100. So 50 out of 100, that's 50 divided by 100, which is about half. 50%. 50% were male. 50% were female. Okay. Visitors one survey called the students about the use of Facebook. And the following table displays the data for the sample of students who responded to the survey. Okay. How many of the students in the sample, what fraction were in the age were 23 and above age category? Okay. Now this one is basically on what fraction were in the age 23 and above. So 23 plus means how many? 137, right? 137 is 23 plus if you try to see here. How many are 18 to 22? 82. Okay. And how many are 23 plus? They're 137. So how many fraction? In total, how many do we have? 219. Let's write that down. Because remember, fraction is part of a whole. Part is how many? 137. Okay, part over whole. So 137 over 219, which is option number D. Yep. Those many students were 23 and above. Okay. Okay, teams in the National Football League, that is NFL, in America are divided into two conferences, the AFC and the NFC. Okay. Now, some teams have animals as their mascots, yeah, and others do not. So yeah, it's kind of like a funny animal, cute animal they just use as a mascot. And then the following two-way table displays the data. So what percentage are in the AFC? So AFC and NFC are just two conferences just think of. And now we're just saying what percentage of teams are in the AFC. So they don't matter like if they have an animal mascot or not. They're just saying what percentage are in the AFC. That's all. So basically we're just trying to see how many students, total how many total teams, right? Yeah, how many total teams do we have? 32, right? I don't know how many people. I think generally it's like 20 or 25 in a team, but it is for the purpose of this problem, they're just giving 32 teams. We don't know how many people in each team. So we'll just write 32 teams. And how many teams are in AFC? So AFC is about 16, right? 16, 16. AFC and NFC. 16 over 32, which is about half or 50%. 50% in NFC, 50% in AFC. Okay, awesome. We did it. And it is, where did I go? Oh, sorry. Think. Where was I? Yeah, interpreting two variables, right? Yes. So, okay, that's what we did. Okay. Yeah, interpreting two variables. Yeah, that's just the part we want to now focus on. So now a survey asked participants whether or not they were vegetarian, how important they thought saving energy was. The table of row relative frequencies below shows the data. So now this is about basically the interpretation of in total, okay, from the total, because remember, now this is two-way tables. Here you can map, okay, here you can say that how what percentage. So 33% are thinking vegetarian, 33% of vegetarians, you can say here, because vegetarians are this one over here, okay. 33% because remember it's adding to 100%. So from them, 30% are thinking maybe saving energy is not important. 70% are thinking maybe somewhat important. 50% are thinking very important. So majority think it's very important. Then is after that some thinking just not important, and then some people are like between the two, kind of somewhat important. Neither like too much or too little. And the non-vegetarians we have is 38% are thinking not important and 26. So yeah, non-vegetarian, they don't think it's that important to save energy. Because vegetarians means they're trying to save energy. They're trying to reduce their meat consumption. They're trying to benefit nature that way. Stop climate change by reducing the amount of meat eating. So based on the data, which of the following statements must be true? Now, how do we interpret this is, now we can say that 33% of people who say not important, they must be vegetarian, okay? Because we don't know, now this is actually given as row relative frequency. So only row relative is being given. They don't give column relative frequency. They don't give us this frequency, okay? If this has been given, because remember, if we add 0.33 plus 0.38, that's 0.70 or 0. I think, wait, what is that? 0.71, which is not equal to 1, right? Because row totals and column totals must be 1. Row totals are 1. They're definitely 1. But if we see column totals are not 1, so that way we can conclude that 33% of not important people are corresponding to vegetarian, or 38% of not important people are considered uh, like considered among the non-vegetarians. We can definitely say 33% of vegetarians are not important, considering saving energy not important. We can say 33% who are considering not important, the energy saving, are vegetarian. Okay, it's like that ways we can see. So row term means we just have to see a row relative based on the row. So based on the vegetarian row, based on the non-vegetarian. Column relative means based on somewhat important, based on very important, based on not important. Which of the following statements must be true? 33% surveyed were not of the people surveyed were vegetarian and thought saving energy was important. Yeah. Now this one we actually don't know how many people were surveyed. Wait, were I think this one is actually somewhat it's kind of flicking. Yeah, because 33% of the people who surveyed were vegetarian, right? Because in total we have one. So we know 33% were vegetarian, but 33% of the people we don't know actually here. So that way this would be kind of incorrect. because we don't know how many people in total we had. But let's check the other options. That ways we'll just map around which one do you think we can choose. So B option, they say if a person thought saving energy was very important, they were most likely to be vegetarian. Yeah, this one we can definitely conclude because column wise we can conclude. That's definitely wrong. Now, a person who was not vegetarian was more likely to think saving energy was very important than not important. This one actually we can because we don't have been given the total number of people who were saving energy, right? Total number of people who have been surveyed. So 33% we don't know. We know that 33% means 33% of vegetarians. We don't know 33% of the people surveyed were vegetarian. Okay. We know 33% of vegetarians consider not important saving energy. 33% of non of vegetarians. We can't say 33% of the people surveyed in total because that is not being given to us. So that ways we have to see this part. The person was not vegetarian was more likely to think saving energy was very important. Okay, this person was not very important, was more likely to think saving energy was, yeah, who was not a vegetarian, think saving energy was very important. Wait, saving energy was, yeah, but they're not thinking, they're in thinking less than, right? Yeah, then not important. Okay, let's go to the other options. I didn't see, sorry. I was like, A, B, C are correct. So which one do we choose? D, I think D should be the best option. Let me just check here. Because A, B, C don't quite fit here. So D, let's check. A person who was not a vegetarian was more likely to think than a vegetarian to think saving was more likely. Oh yeah, this one we can conclude, yes. Because that is row wise we're concluding. So who was vegetarian was more likely to than a vegetarian to think saving energy was somewhat important. Yes. Not vegetarian is more, yes. 17% of vegetarians think it's somewhat important. 36% of non-vegetarians think somewhat important. So yeah, the person who was not vegetarian was more likely than a vegetarian to think yes. They were more likely to think that it was somewhat important, but they were less likely to think it was very, very important, right? Because 26% is less than 50%, 70% is less than 36%. So yes, these are best bet. There we go. Yeah. Okay. We can even study this if you want. So let's study. Yeah, statement one. So yeah, we know the relative frequencies. Yeah, we don't know the table relative. Yeah, now this one matters. Column relative, table relative, and row relative. We have three relatives. Okay, so we want to see according to the table relative. We don't know like in total how many people were there. They don't give us any information for how many people were there. They just give information on that these many vegetarians were there, these many non-vegetarians, and they just give them to 100%. So we don't know how many vegetarians, and non-vegetarians were in the first place. We just know that 33% think it's not important, 70% think it's very important, 30% think it's very important for the vegetarians. Non-vegetarians, we just think 38% is not important, blah blah blah. We don't know for those specific ones in total how many did we have before, or how many people in total were thinking it's somewhat important or very important. So that also we can conclude. Statement two is where this is also column relative frequency claim, so that's why this was incorrect, right? Because guys, if you see here, this is just trying to show an example that say if we had a sample of 400 people, okay, of whom 100 were vegetarian, 300 were not vegetarian. If you try to see 0.50 of 100, that would be 50, and 0.26 of 300 would be 78, right? So without knowing how many people were there, we can conclude anything. We don't know how many people were there in the first place, because there it's not even guaranteed that there were equal numbers of vegetarian and non-vegetarian. If they were, okay, if there were equal number of vegetarians and non-vegetarians, then surely this statement would be correct. Statement two. If a person thought saving energy was very important, they were most likely to be a vegetarian. But it's not been, given here any information on that. We don't have any clue on how many people were in all, how many people were vegetarian, how many people were not vegetarian, how many people thought somewhat important and stuff. We can conclude based on column relatives. So yeah, that way we can accurately conclude that this one is definitely true. This could be true, this could be false. It depends. So we can definitely say no, not a vegetarian was more likely, and this one is actually contradictory because you see, 26% is actually less. Okay, it's not more. Who was more vegetarian was more likely to think saving energy was very important and not important. Well, they were thinking 26%. Now they are saying that we were more likely to think it was very important. Well, 26% and 38%, 26 should be less. So they were less likely to think. Okay, they were not more likely to think it was very important. They were less likely to think it was very important than not important. So yeah. And then yeah, statement four, as you guys see, it is going to be correct. Because that way we see 36 is definitely more than 70. So yeah, that's how we make a conclusion based on two-way tables. Now, Alvaro is interested in the relationship between weather conditions and the weather that I'm trying to train runs of time. For a year, he records whether each day is sunny, cloudy, rainy, or snow, as well as whether this train is delayed. So he's just recording that, what is the weather condition and then if the train is delayed or not. Because, it's during snowy days, sometimes it's been delayed. So he's just kind of recording all this stuff. Now here it's basically row relative and column relative. I think both of them. Yeah. Now here we can actually conclude both of them because we do have all the information here. If it's not like just being given in those, percentages that these many percentage of this on these many percentage of trains were on the sunny. It's not like a row relative. Row relative means it could be something like this, where 50% are on time and 50% were delayed on a cloudy day. Okay, something like that. But here it's basically on the number of records they've been given. So here we can surely go around. We can just see that this way you can see. We can even see this way. Relative, column relative, table relative. All three relatives we can see. So let's go to the options and just see which of the following statement will be correct. And I can even draw something of my conclusion that I would say the number of delays were the highest on especially rainy days. Yeah, rainy days I would say it was mostly the highest. And then the number of on-time trains that were there on times were highest during sunny days, right? Because generally you can conclude if it's sunny, it's generally on time. Delayed is pretty less, especially if it's a mechanical issue or something. But generally on sunny days, it's generally on time. So yeah, otherwise we can conclude on that part. But let's go to the option. It was more likely, on sunny days to be less. It was less likely on sunny days to be delayed, and more likely to be on time. That's something we can make. But let's see. When the weather was rainy, it was more likely for the train to be delayed than on time. Okay. When the weather was rainy, it was more likely to the train to be delayed than on time. Well, that is false. It is 15 times delayed, but it is 40 times on time. So we can definitely say it's going to be more likely for the train to be delayed than on time. Because if you see 40 divided by 55, let me write here. You can even use a calculator to convert into percentage. But now if you just try to see both of these frequencies, they're just saying that they're saying it was more likely to be, and this is on time, right? OT, and this is T. So here they are saying it was more likely for the train to be delayed. So this is more likely. So here they are just trying to say that this one is greater. And well, this is a correct. This can't be greater. 30 over 55 is greater. So it's more likely to be on time than to be delayed. But when the weather is snowy, if you go to the B option, because A is incorrect, so if you go to the B option, more likely to be delayed than on time. Well, this one makes sense actually. Well, let's see that. See. And actually, this makes logically sense, right? These snowy days is generally more delayed than on time. So 8 over 20 and 12 over 20. Here they're saying that this is T, this is OT, and they're saying 12 over 20 is actually greater, which is actually mathematically correct. So B is correct. B is the option we choose. But let's see the other options as well. More than half of the delays occurred on 20 days. Well, more than half. Okay, how many delays do we have? 35. How many delays on 20 days? 50. Is 15 the half of 35? Well, no, right? 18 is the half or 17, I think 17.5 or something. So it's actually less than half of the delays on 20 days. It's not more because 15 is less than half of 35. So this one is also incorrect. Now the most delays came on snowy days. Well, most delays came on rainy days. Highest is 15, highest is not 12. So yeah, that is also incorrect. So that way we conclude B is the only option that is going to be correct. There we go. Okay, now let me just erase all of this up here. Go to the next one. Now we just want to interpret column relative frequency. So yeah, now this one is actually where it's column relative. Okay, not row relative, it's column relative. Now here if you just try to kind of model now this one, you can't conclude that we can't conclude like this. We can't say something like 31% of in-person people have no network access and 20% of in-person people have internet access. Okay, because that is not even given here. If we try to add this is 0.51. This is not 1. In column relative and row relative frequencies, we want this total as 1. We don't have 1. We have 0.51 as the total. So we can't make that assumption. We can definitely say that 31% of no internet access people are in person. They like to communicate in person. And 15% of no internet access people like social networking. And 8% of no internet access people like wired telephone. So that we can conclude, but we can't conclude the other way around. We can say people with no internet access like this. So people, these many percent of people with no internet access like this and that, blah blah blah. But for these many percent of social networking people like this we can conclude accurately. So yeah, this is just showing like whether a person has internet access and the preferred method of communicate with friends. Preferred method is just, these five ones. And then they're just saying which of the following statements must be true. So we just study through the methods. Now here, based on this method, if we try to, make a logical conclusion, we can say, well, we could say the percentage of people. So basically, as if you have internet access, then you're more likely to prefer text messaging than someone with no internet access. Okay, that's a conclusion we can make. So first, internet access. Internet access is the first condition. So if you have no internet access, then you're more likely to choose in person. Of course, right? That makes sense. In person or text messaging, because they work without internet. If you're with internet access, then you're more likely to choose text messaging. Maybe it's because most people, they prefer that way, but you're less likely to prefer in person because you have internet access. So you're less likely to prefer internet access. People are less likely to prefer in person communication, and they are much less likely to prefer wired telephone compared to those with no internet access, like the old school telephone wires. So if you see here, which of the following statements must be true? A person who prefers to communicate with friends is more likely to be have internet access. Well, this one we can definitely, because a person who is more likely to communicate with friends in person. But well, we can conclude based on in person because this is not a relative. We can conclude like this. We have to conclude like this. This is the correct way. This is incorrect. We can conclude like this. We have to conclude like this. A person with no internet access is this, is this. We can say person with in-person with friends preferation, or like preferring in-person communication is going to be more likely to have internet access or not. That is not something we can include on relative. We have to include on column relative frequency. So yeah, if we take a look here, that's definitely incorrect. Okay, I can even give it. Okay, yes. Actually, let me just give that takeaway here. Yeah, that looks true. Now, if we take the option over here, let me change the color to red. Okay. Now here we see a person with internet access is more likely than a person with without internet access. Yeah, this one we can conclude that a person with internet, because this is internet access in the start of the sentence. So we have to make our statement based on if they have internet access or not, not on based on in person or social networking or whatever their preference. So with a person with internet access is more likely than a person without internet access prefer the wire telephone to communicate with their friends. Well, this one is actually, if we take a look now, see, 0.0. So actually, they're less likely without than a person, right? They're less likely because wire telephones generally don't require internet. So the person with internet access is actually less likely than a person without internet access to prefer the wire telephone. That would be incorrect. Yeah. So A and B are incorrect. We just rule them out. Now, if we take to take a look at C and D, I'll just erase this. Yeah. Now, if we take a person with internet access is more likely than a person without internet access to prefer text messaging to communicate with their friends. Well, this one is actually kind of true because 0.54 is more, right? 0.54 is more than 0.31. So yeah, this one is correct. If we take a look at B, well, people without internet access prefer using social networking than people with internet access. How come? Is social net actually that is opposite. They prefer less. They're less likely to use social networking because they are more likely to prefer text messaging, and they're more likely to prefer, I think, in person, right? Yeah, in person text messaging or other ways than wired. I mean, like, wait. Yeah, without internet access prefer social networking than without. Oh yeah, I'm sorry. I think I'm mixing up. Sorry. Okay, wait. See, a person without internet access prefers using social networking than people. Okay, more people without internet. So yeah, now this one is actually where they're saying more people without internet. Well, we don't know the number of people here, so we can't say more people. We can say they're more likely to do this or they're less likely to do that. That is frequency based conclusion on this because we don't know how many people are there in total. Okay, if we had say 100 people over here, this is say 200. Now if we try here using social networking, 0.15. Now 0.15 of 100 is actually about 15. 0.8 about 200 is 60. So 60 is actually more, right? So we don't know the number of people. We can definitely conclude based on more people or less people. We can just say it's more or less likely. So here is this. And yeah, the option will be it's more likely than a person without internet access. Yes. To prefer the wired telephone. Yes. They're more likely to prefer the wired telephone to communicate with friends. Actually, I was incorrect. Sorry, guys. What am I choosing? I think it should be. Yeah, I was going to choose C. Sorry. Actually, B was incorrect. We need that. Yeah. Okay. If you take a look here. So yeah, that way you guys see this all the explanation given here. So basically, in conclusion, if you read here, we know the column relative frequency is not the row relative frequency. So yeah, first option definitely rules out. B option definitely rules out because 1 person is actually less. A person with internet access is actually less likely to use wired telephone. Why would they bother with wired telephone? They're less likely to use it than someone without internet access. So B and A are incorrect. If you check D, now D is why is it incorrect? Because we know the relative frequency is not the actual counts of people. Yes, we can say more or less people. We can just say more likely or less likely. We can just say the chance. They're more likely or less likely to use than a person with this. So we can just say their percentages. Okay, this many percentages would prefer this, or these many percentage would prefer. So in all, from all the people with internet access, these many people are more likely to prefer. Okay, that we can say definitely because percentages are higher. But we can't say more people like this, less people like this. We don't know the exact actual counts. A large, yeah, they say here. We only know the frequency is not the actual counts of people. So large population with people with internet access would mean more people with internet use accessing prefer using social media. So yeah, a large enough population of people with internet access, that would mean that more people actually with internet access prefer social networking. So that ways we can make a logical conclusion because we don't know the number of people, right? It could be 200 for say, as I said, 200 for internet access and 100 people for no internet access. So we don't know that part. So that's why we can't make a reasonable conclusion. Let's take a look here now. So two-way frequency table shows the data from a random sample of 93 students on there. My recording is there. Okay. Yeah. Okay. It shows data on a random sample of 93 students on their favorite season and whether or not the student has allergies. So yeah, this one is basically on showing data below here, showing the data on random sample of students. So 93 students are there. Some students have allergies, some students have allergies. So this one is actually now, this one is simple. This one is column relative, row relative, and table relative. We can say three of them. Let's check the four options here. And we can even say something like, most students with no allergies. Most students have no allergies during summer than have. So actually, a student is less likely to have allergies during summer. Okay, that's because 13 is less than 23. So we can make a logical conclusion based on that. And during spring, or yeah, I think it's almost for all because almost for all a person is, yeah, it's always less, right? So then no allergies. So most likely here a person during summer is also less likely than a person during, what do we say, wait. Yeah, we could even make a conclusion like, because 13 over 36, if we try, it's going to be less than 14 over 30. So a person during summer is less likely to have an allergy than a person during fall. We can say that. Okay, we can just compare like that and then we can just map it around. We can even divide into decimals and just see here. Well, let's not get into that. We'll just see the option, look at the options here below. So which of the following statements is true for the students surveyed? Student with allergies is less likely to have spring as their favorite season. So these are just the favorite seasons, and if they not have allergies or not. And so a student, yeah, a student with allergies is least likely to have spring as a favorite season. Now, okay, this one is not actually based on the season. Okay, this one is based on if they like that season or not. So students who like summer season, they are less likely to have allergies than person who likes fall, you could say. Based on the total number of people, students who like fall, a person who likes summer is less likely to have allergies than a person who likes fall. That's something we can make here. But student with allergies is least likely to have spring. Well, this one is with allergies, right? So with allergies is least likely to have spring. So student with allergies. So we see here, student with allergies. How many students have allergies? 38. Is least likely to have. Well, actually, they're least likely to have winter as their favorite season. So because 5 is the least. 30 is not the least. So that's one is incorrect. A student was most likely to have summer as a favorite season, whether or not they like allergies. Yeah. A student was most likely. So out of 93, a student is most likely to have summer as their favorite. Actually, that makes sense, right? Yeah. It's most likely to have regardless of weather. The allergies don't matter here, but most students like summer because 36 is the highest. That makes sense. After 36 comes 30. That is the second highest. So B is the option we choose. Let's take a look at the other options. I think student with no allergies is more likely to have spring than fall with no allergies. So 55, right? Yeah. 55 is where, yeah, 55 is where they have no allergies and is more likely to have spring than fall as their favorite season. So it's more likely during no allergies. So no allergies is 55 over here. They're more likely to have, let me see, 55 don't have any allergies. They're more likely to have spring than fall as a favorite season. They're more likely to have spring than fall. Well, no, they're actually likely to have fall as a favorite season, not spring, because 16 is actually high, it's not lower. So this one is also incorrect. If we take a look at option number D, B is the correct one, but D is more likely to have no allergies, no matter what the favorite season was. Yeah, more likely to have no allergies. This one is also something. Let's see. Take a look. See. Yeah, this one is actually where more likely to have no allergies, right? No matter what their favorite season. Yeah, this one is also makes sense. D also makes sense. But here, based on this one, what we want to conclude is student was most likely to have summer as okay. Let's see. I think B and D should be the options here. Let's choose between the two. So most likely to have summer as their favorite season, whether or not they have allergies. So comparing to the number of people like summer, 36. So whether or not they have allergies, more likely to, yeah. Out of 93, out of the total, student was more likely to have no allergies. Let's choose D and C actually. Okay, I see. And actually B is they incorrect. Okay, let's study B because B was a little bit confusing. Let's see. Okay, so for B they're saying is there are 30 students of the 38 who have allergies, who have oh yeah, 13 out of 38 who have allergies. 38 have allergies. So whether or not they have allergies, we'll just see. More likely to choose summer. 13 out of 38 who have allergies, who have summer as their favorite season. Yes, 13 out of 38 have summer as their favorite season, but there are 14 who have fall as their favorite season. I see. I think they're just trying to say here is 14 is the highest. Yeah, 30 is actually lower. So that way, yeah, that is why B falls incorrect. And if you take a look here, this one is something worth studying. So if the student had no allergies, they were most likely to have summer as their favorite season. Yes. Now see if let's take a look option here. However, 13 of the 38 students who have allergies have summer as their favorite season, but there are 14 who have yes. Okay. They're just trying to compare here. So yeah, if you just try to see here, the number of students with no allergies, 23 is the highest. But the number of students with allergies, that's where 14 is the highest. Yeah, I see. So I think that's where it fails up. Okay. Well, let's do this bonus question as well. So two-way table is just showing the rate of frequencies below, summarizes the survey data on who a person's role model is and their highest level of education. Through role model versus high level of education. Someone's role model is some family member, some stranger, some friend or acquaintance, and then their education levels. And then which of the following statements must be true? So now this one is basically where we have actually column relative. Yeah, column relative frequency. Column relative frequency is summarizing. So yeah, we can say that person whose role model is family member, they're 23% of person whose role model is family member, they're they have completed bachelor's degree. So actually the we have here is a person whose role model is a family member, their education level is most likely to be some college. Something like that we can say, right? Because some college is the highest for that part. But we can say person who is in some college because this way we can conclude that a person who was in some who has done bachelor's degree is more likely to choose friend or acquaintance or is more likely to choose a family member, is more likely to choose stranger stuff. We can make only column relative, we can make row relative. Let's take a look here. A person whose role model is a family member is less likely to have an advanced degree. So yeah, this person is a family member. Yes, whose role model is a family member is less likely to have an advanced degree. Oh yeah, that but actually then a person whose role model is a friend or acquaintance. That is actually completely incorrect, right? Because 0.14 is actually the highest. So a person whose role model is a family member, yes, whose role model is a family member, they are actually more likely to have an advanced degree, right? Because family members can inspire them. So it's actually it's actually more likely to have an advanced degree. So and a person whose role model is a friend or acquaintance. So 0.14 is actually more than 0.12. So they're actually more likely to have. But if we take a look here, a person whose role model is a stranger is more likely to have a high school as high school then college as their, yeah, a person whose role model is stranger. Now let's take a look at all the strangers here. So they're comparing what parts? High school and some college, right? So some college versus high school. So actually, they are more likely to have high school than some college. Yes, they are more likely to have high school than some college as the highest level education. Yes. Person's role model is a stranger. Yep, that conclusion we can make. So B actually fits here. See, if we take a look, a person whose highest level of education is a bachelor's degree. Yeah, this we can't make. No, because this is column we can't make a role relative frequency conclusion. Whose highest level is a bachelor's degree is more likely to have a family member than a stranger as a role model? No. We don't know this way. We just know this way. So we have to just make conclusion based on data this way. We can't say person first condition should be always the column here. This column relative means first. So person given that a person's role model is a family member, blah blah blah. We can say given that a person has completed bachelor's degree, blah blah blah. Something similar to that. And then, so C is definitely incorrect. If you take a look at B, I mean, sorry, D, B is correct, but D, if you take a look at whose highest level of education is, okay, whose highest level of education is less than high school is more likely. So, yeah, whose high level of education is, okay, this one is also actually something is column relative. So, yeah, that also conclusion we definitely can make. I mean, so rule relative we can't make because we can't say a person whose highest level of education is less than high school because that would be going this way. That way we can't. We have to go this way. This is correct. This is incorrect. So yeah, B is the only one we can choose. Therefore, let's check it out. Got it correct. Okay, guys. We'll discuss more in the next session on mosaic points. Okay. So yeah, bye for now and see you guys in the next video.